So now, if I put it on the side of the cube, the minor axis is not going like this. The minor axis is going to that VP. Whoa! Because it's perpendicular to the side of the cube. Yeah! And then, wait for it, if you have a 90-degree angle, what do you know about the major axis? It's perpendicular to the minor at all times. And it would go right about there, and then I'll point out one additional thing that is going to mess with your heads. But do you see that?
Yeah.
Does everybody understand that?
Yes.
Yes.
So, every time you're drawing the minor axis, you need to think about it as being perpendicular to the plane. Now, if you have a level ellipse, a manhole cover, it's a vertical line, usually. But if you have it on the side of a car, like for a tire, a tire's minor axis is parallel, is going to the same vanishing point as the lines going across the car. Make sense? As the axle, basically. It has the same VPs as the axle of the tires. Does that make sense, Rachel? You got it? Okay. All right, now, are you guys ready for me to mess with your head a little bit? Here's the thing. The minor axis is passing through the center of the ellipse and the center of the square. The major axis does not. The major axis is in front of the center of the square. So the center of the ellipse and the center of the square are not the same point. How is that possible, John? Well, let me show you. What is the major axis? The major axis is the widest point of the ellipse. The ellipse at its widest point. Okay? Now, you guys look at this and you think, now wait a minute. That's the widest point of the circle. Why aren't they the same thing? Because, let's say we have a viewer here. Everyone watch this because you're going to get lost if you look down here. So just watch for a second. Here's my viewer. If I look at these lines, do you see that they cut inside the circle? So that's not the widest point of the ellipse. The widest point of the ellipse is here. That's the major axis. Now, why does this work? Remember how I told you that the ellipses are always identical? They're always symmetrical? Visually, because of foreshortening. Let me draw it this way. So when you're looking at an ellipse, it's always symmetrical. What I'm saying is that that area visually is equal to this area. Does that make sense?
Yeah. Yes.
So the major axis will never, ever be at the center of a square. It will always be in front of or slightly closer to the viewer. You see what I mean? Because this point this is the center, for those guys who aren't sure, this is the center of the square and the circle. This is the center of the ellipse. Make sense? Now, if you want me to prove it to you, here's how I can prove it to you. if I bisect this, there's the center of the square. Does that make sense? So this is why, now here's what drives me crazy. Why isn't this in a book? In a really clear way. Because this is why people draw ellipses wrong. They try to, they don't understand this relationship. And if you understand if you approach it from the standpoint of drawing the major and minor axes correctly, you will. Okay, so here's my cube. So let me just go ahead and draw one on the side plane first. Okay, because the top one, that one's the easy one. Everyone pretty much gets that from an orientation standpoint. So let's try drawing it over here. So the first thing I have to do, and this is actually, and you guys, this is what you're going to have to do on the homework, because your homework is going to be to do 20 cubes with ellipses on visible sides. Okay, so 4 sheets of 5, same thing as before, but okay, so you're going to have 20 cubes plus the ellipses that go with them. If this is my square, I'm going to start by bisecting it to find the center. When I find the center of the square, I now have my minor axis. My minor axis is going to be going to the opposite VP, so my minor axis for that ellipse is going to look like that. Okay? Now, I'm going to talk about how I find the length in a second. Shelve that for a second. Just trust me that it's about right. Okay? And I'll explain how I do it later. For right now, just concentrate on orientation and the relationship of the axes to the center. So I know it passes through the center. Now I can tell you that my minor is going to be about like that. Trust me on this. We'll explain it in a minute. Now if I do that, do you see that if I take that line and I divide it in half perfectly, do you see that I find a point right about there, just in front of, just a little bit closer to the viewer than the center of the square? So this is a perfect division of those two. All right? Now at that point, if I take, whoops. A 90-degree line through that, that's my major axis. Yeah, Patch.
Couldn't you have just taken a 90-degree line off of the, couldn't you just bisect the minor axis and then just put a 90-degree line there?
Yes. Yeah, that's what I normally do, but I wanted to make it really precise.
Okay, gotcha.
So yeah, basically I divide this in half and I draw a 90 and I'm good. But I wanted to make sure it was exactly 90. All right, now here's one little aside. Don't get confused by this, but one little aside. Do you see that if I had the spots of a die on here? So I had, say, an ellipse here, 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 and here. Do you see that all of the angles would be different?
Mm-hmm. Yeah.
That's what people screw up if they don't know how to do this. So that's how I can look at it. They'll make them all parallel or something like that. Yeah.
I'm sorry, I just have a question. So why is the major axis, like the red line, slanted? Like,
The red line is the minor.
Okay, oh, it's the minor.
Yeah, and it's slanted because it's going to the same VP as all those guys. Yeah, it's your finger poking through the CD. You know, if you imagine the CD on the side, well, this finger would be going to the VPs on the opposite side. Yeah.
So John, if I wanted to find the minor axis, could I just find the visual center of both sides of the square and go straight through from one side to the other?
That's what I'm about to show. That's actually that's what I'm about to show you. Yeah.
How'd you find the direction of the major axis? Like, how'd you know?
It's perfectly 90 degrees off of the minor every time.